Good day and good morning, everyone, depending where you are. My name is Tony. I'm a course advisor, and I will be your host for today's webinar session. Before we start, I'll just like to give some housekeeping rules. So on your screen, these are the notification and sound settings. So you are able to turn on and off the notification sound as you wish during this session. And please do post any question under the Q&A function at the top right-hand corner. You will see there is a Q&A. So you can post any questions that you may have. There will be a Q&A at the end of the session. So if the questions are related, technically related, then our presenter for the day will be able to assist regarding that. But if it's a general question, I'll be able to assist regarding that. And these are some of the frequently asked questions. So everyone registered for this webinar will receive a copy of the PDF slides and a link to the video recording within the next 2 business days via an email. So please do check your junk folder, spam folder, if the email does not appear in your inbox. And we will also provide a free digital certificate of attendance for live attendees. So there will be a link which I'll be sharing and a QR code to a short survey that will be provided so that you can get your certificate of attendance. And you need to claim the certificate of attendance within the 48 hours because it does expire after 48 hours. Just event conduct. So please keep the discussion lawful and respectful. Follow the moderator's direction. Do not share illegal or abusive content. Recording is not permitted unless authorized. Breach may lead to removal and referral under the ECT policy. So just a bit about ECT. So ECT is affiliated to the well-established Engineering Institute of Technology, EIT. Is an engineering education specialist. We deliver bachelor's courses and master's degree. So our programs are designed by industry experts, ensuring that you graduate with a cutting-edge skill that are valued by employers. So ECT is registered and accredited, meeting the Office for Student Recruitment for course quality academics, standard, student support, and student protection. Our lectures are subject specialists with industry experience and the academic qualifications. We also do offer a unique delivery mode. So we deliver our programs via a unique delivery methodology that makes use of live interactive webinar, tutorials, where you are also be able to record. You do get recordings of the classes. You can always go through them at a later stage. And today's topic is visual power plants as flexibility providers for resilient grid. And our presenter for the day is Dr. Mohammed. Dr. Mohammed, you can take control of the slides.
Yeah, thank you, Tony. Hi, everyone. I am Mohammed Kais. I'm a lecturer at ECT, and I'm happy to present this topic in this webinar, which is virtual power plants as flexibility providers for resilient grid. So this is actually new technology in our system, and
Dr. Mohammed,
content. Yes.
Just to interrupt you, can you just take over the slide, take control of the slides?
This one, you mean?
Yeah, take control. There's where it says take control, I think. If you can just look up.
I'm controlling now, I guess.
Is it you're controlling or it's not moving on my side?
I think
this up there, this where I think where by the chat box up there is where it says take control. Does it give you that option by the chat box? Just
okay, chat.
On the chat, just next to the chat box, there is where take control. I'm not sure if it does give you that option.
For me, I can control now, but I don't know about
because on On my side, it's not moving, but I can do it on my side. I can move it on my side. I'm not necessarily sure where you are at the moment.
Okay.
Are you by the contents?
Take a control. I'm now taking
Yes,
a control.
yes. That's perfect.
Okay.
That's perfect.
Yeah, now. Okay. So the contents of this webinar will discuss about why we need virtual power plants. So for UK, the net zero target by 2050 is one of the reasons of emerging virtual power plants. What are the future challenges? What is VPP? And what is the topic of residential virtual power plants? And what are the effects of future EV demand on the power system? And how VPP can coordinate these EVs and the impact, some results of my research about VPP and Tesla VPP as a real world example. So for UK, actually now UK target, which is net zero carbon emissions. So for example, I'm going to compare the 2019, how the energy in the UK and how it is expected in 2050. So we can see that, for example, here we can see that, for example, how to make this, how I can make it, okay. So you can see 2019 that natural gas, oil is mastering the generation of the energy, and most of the, for example, heating and transport is depending on the gas and oil, which is clear as we can see, for example, the gray color. But for the 2050, we can see that the natural gas will be reduced and oil, and mostly it will depend on the renewable energy resources such as wind, solar, and nuclear. And the heating of building will be mostly based on electricity, and also transport will depend on the electricity. So this will increase the demand in the grid, and also the wind and solar, because of their intermittent and their their stochastic nature, so they will make some balance problems in the grid system. So for the future challenge, we have high penetration of those distributed energy resources in the electrical grid may introduce a variety of detrimental conditions. So we will have some issues such as the balance of between demand and supply because of the intermittent of the renewable energy resources. And we have also problem in the load profile, such as the duck curve. This duck curve you can see, which appeared in California. So because of the solar generation, we can see that for example, high the slope of the demand, how it is sharp from, for example, in the evening, and this will cause high peak demand that can affect the balance of the between demand and supply. In the conventional, actually, in the conventional grid, usually the supply follow the demand, but not after or in the future because of the for example, nature of the generation and the demand. Then we are expecting the demand will follow the supply. So based on the forecasting of the solar and wind, then the demand will be coordinated to be, for example, supplied during the availability of solar and wind. So some of the future challenges, for example, when wind farms actually will be the dominant source in the UK, and the problem that wind farms only operate from between 4 and 25 meters per second. This is the wind speed. So we have two problems. Either the wind speed are lower than 4 meters per second, which can be called as calm wind, and the generation will be zero. We, as experienced in UK in 23rd of January 2025, we can see that from 2022 to 2023, the net generation of wind in UK was almost zero. That it was, for example, here you can see it was 15,000 megawatt or 15 gigawatt during the, for example, normal wind speed. But during this calm wind speed, the generation was almost zero. And also we have another problem of the curtailment of the wind power plants due to the low demand. And this also will cost the utilities because of this power curtailment. And the other things that if the wind speed is higher than 25 meters per second, also the wind power plants will be also curtailed. Another problem, we have the extreme weather that will cause some faults and outages in the grid. So these are many issues that will the frequency of these issues will increase in the future, and the grid operators need to face and to prepare the grid for these issues. So based on this, we have flexible assets that can be controlled and should be addressed using utilities or either energy suppliers or virtual power plants operators or aggregators. So these flexible resources can be generation, storage, demand, and this generation in the future mostly will depend on the weather-dependent resources such as wind and PV, and those PV can be either ground-mounted or rooftop that are installed in the rooftop of, for example, residential buildings. And the storage, we have either large scale or small scale, and the small scale mostly that are installed in also residential buildings. We have also EVs that the number of EVs will increase in the UK because of the electrification of transport, and the number of chargers will increase mostly in the residential areas that will maybe cause in the future problem in the distribution networks, such as voltage drop and voltage collapse. For the demand, we have residential, commercial, industrial demand that can be controlled for residential, such as heat pumps, because of the also heat electrification in the UK for zero or net zero carbon emissions. So all these flexible assets can be clustered based on either power flow direction, such as we have energy storage that have bi-directional flow, or unidirectional flow, such as load and generation. For the duration also, and how the upward ramping rate includes the response time and the maximum power that can be injected to the grid, and also downward ramping includes the response time and the minimum power that can be injected. Availability time, such as the solar radiation period, the idle time of EVs, available capacities, such as the capacities of the batteries and EVs, magnitude of injected power, and demand side flexibility. For example, for charging points, for example, in Edinburgh, there are many charging points are installed in different areas and with different capacities. We can see that we have the range of those capacities varies between 7 kilowatt till 350 kilowatt. So these are the charging points that are available in UK and specifically here in Edinburgh, and those can be clustered based on the injected power. So what is virtual power plant, VPP? VPP actually is a cloud-based network of generators, consumers, energy storage. So VPPs leverage the technology of Internet of Things, IoT, to aggregate and coordinate the supply and demand of distributed energy resources and consumers. So VPPs will aggregate the distributed, for example, rooftop solar panels, the distributed energy storage, the demand response, and it is responsible for predicting the generation of those solar or wind, and also the demand of the customers. Then it will coordinate these or orchestrate the operation of those demand and supply to work together and either reduce the cost or support the frequency regulation of the grid, or support the distribution, the voltage of the distribution network. So the application of virtual power plant is the residential. There are commercial or different virtual power plants that are already emerged in UK and Australia, Japan, USA. So these virtual power plants can aggregate either large scale, which are already existed, and it can aggregate the small scale storage or resources. This special virtual power plant is called, for example, residential virtual power plant, that will aggregate the solar and battery systems that are installed in the zero energy houses. Then also the controlled load, such as heat pumps. Then it coordinate them based on the dynamic prices, or based on the forecasted generation and the demand for the grid. So VPP actually operation, it predicts the generation, the prices, the weather, the also demand, and optimize the aggregated resources to work together, either, as I explained, either to reduce the cost of the operation or support the distribution, the ancillary services of distribution network, such as voltage or thermal loading of the transmission lines, and also the frequency regulation of the grid. So the optimization methodologies can be applied for VPP. It depends on the objective in the also model. For example, we can use the linear programming as the deterministic optimization that can optimize the operation of the to optimize the operation of the, for example, the distribution network or the total grid. Also, stochastic optimization can be used, especially if the model is non-linear and we cannot linearize the model. So stochastic optimization is one of the solutions that can be applied to solve the non-linear model. For the reinforcement learning, this is the new optimization methodologies that can solve the nonlinear model, and that can be scalable to any number of the distribution energy resources that can limit the optimization process. So, for example, here we have the result of effect of the future EV demand on distribution network, and we can see that the number of EVs, the increasing number of EVs, will affect the voltage of the network, because here the lower limit of the distribution network in the UK, the lower limit of the voltage is 94%, but the increasing number of EVs that require charging will increase. This increase of the demand will affect the voltage limit of the distribution network in the UK. And we can see the generation of the PV, how it affected also the net demand in the net demand is in the violet color. We can see how the peaks are in the night and the evening, but during the midday, the net demand is almost zero because of the generation of the rooftop PVs. So if we apply the virtual power plant to coordinate the charging of the EVs, then we supported the voltage limit above the 94% of the distribution network in the UK. And at the same time, you can see in this, the violet or the purple color, the demand is almost smooth because of the coordination of the virtual power plants. So now the storage, for example, the energy storage is utilized to supply the peak demand at this orange color. So now this is supplied by the batteries, and the also the demand that is in purple is almost smooth than the previous one. So this is also the results of research how the virtual power plant can orchestrate the demand or the charging and discharging of EVs, because now we know that EVs can be utilized in the future as vehicle to grid. So we can see that the voltage is maintained above the 90%, 94% of the distribution voltage, and also the health of the assets such as transformers and transmission lines is maintained with VPP. And the consumer benefit also is improved, where the cost is reduced by 44%. So these are the results of the VPP in the residential VPP especially. So we have as a real world application in the residential VPP that Tesla offers home solar panels and Powerwall system designed to save on energy costs and sustainable power homes. So this Tesla energy with the Tesla VPP has been applied in different countries, such as South Australia's virtual power plant is a VPP. This network of potentially 50,000 solar and Tesla Powerwall home battery systems across South Australia, forming the world's largest residential virtual power plant. In Puerto Rico, VPP, which includes over 63,000 participating Powerwall owner, and this is the, you can see this is the map or the dashboard by Tesla that is controlling those 61 or 63,000 of Powerwall, and the aggregated power is 50 megawatt from only those residential batteries. So this is an example of residential virtual power plant. And in UK, recently in 2026, the Ofgem has licensed the Tesla Electric for virtual power plants. And you can see this is also the app of controlling the Powerwall batteries in the residential buildings. And also Tesla VPP is also applied in Texas and California and Japan. So this is the benefits of the virtual power plants, especially the residential virtual power plant, to support the future challenge of the grid. So virtual power plants can aggregate small everyday energy assets and orchestrate their operation to function as a virtual large-scale power plant. Thank you so much for listening, and I welcome any questions or thoughts you may have.
Thank you very much, Dr. Mohammed. That was very informative, and I hope also the attendees think the same way as I feel now with the information. So yeah, we can take questions now. You can just post any questions that you may have, and Dr. Mohammed will be able to answer those.
Yeah.
And just our upcoming courses, upcoming programs at ECT. So you can see on the right-hand side, those are the programs, Bachelors of Engineering, Honors Industrial Automation, Electrical Engineering. There's also Masters. And on the right-hand side, those are the start dates for the programs. And another thing is that we have a professional certificate, which is basically a skills development course. If you want to upskill yourself in a certain area within the engineering space, you can do the program. And we also are running actually a promotion. So for a limited time, you can save £334 on our 3 months online professional certificate delivered by ECT affiliated institute EIT. So you can enroll by 30 November 2026 and pay just £600 instead of the £933. So I'll be sharing the link now for that promotion on the chat box. Okay, I think there's a question. There's a question for you, Dr. Mohammed.
Yeah.
The question reads, what policy and regulatory changes are necessary for African utilities to adopt virtual power plants successfully?
Yeah, actually, virtual power plants actually they will support for example, the frequency regulations and the energy markets of the utilities. So the changes actually that are required, for example, the energy market, the dynamic pricing, the prices, the also the we can say that how the auctions markets that can be offered for the VPPs to support the grid or to support the frequency regulations. These are the main things that are related to the energy market that need to be to change in the either African or any world countries. Yeah.
Yeah. Okay, that's great. I hope it does answer the question. And on your screen now, so this is the QR code. So if you want to, or you can scan your phone to claim the certificate of attendance using this QR code. So I'm going to also be sharing the link on the chat box. So just a reminder that it expires after 48 hours. So you have to claim the certificate in in less than 48 hours then. So let me just share the link now for that. Yes, I've shared the link on the chat box, so you can do it. Just a reminder, 48 hours, it does expire after that.
So I think this is for the ECT, what is the duration? Do you have the information?
Excuse me, doctor?
There is a question, what is the duration of your PhD program? I think ECT does not have.
Yeah, I think it's for it's the sister company, or the sister company, which is EIT, does have Doctor of Engineering. Yes. So I'll just take your details, Uku, then I'll forward you the information regarding that. Okay, Jasim, yes, you will be sent the recording in the next 2 business working days. Just check your junk folder, spam folder if it does not appear in your inbox, but it will be forwarded to you. I don't see any other questions. There's someone typing, I'm not sure, but we are almost at the end of the session. Let's just wait for Abdallah just to type. I see he's typing. Might be a question, hopefully. Hey, the question, can someone run an engineering postgraduate program remotely? Yes. Yes, you can run it remotely. So we do, as I've said, that we do have, we use in a live interactive program. So you are able to study from the comfort of your home. Yes, even in Nigeria, you are able to study even if you are in Nigeria. I hope that does answer the question. Any more questions for Dr. Mohammed? I don't see any other questions. I think I think they don't have any more questions, Doctor. So on the screen, these are the contact details. So you can just reach out to us if you want more information, and our professional course advisors will then reach out to you and assist you. Any last words from you, Doctor, before we close it?
Yeah, thank you, and I was happy to present this topic in this webinar, and thank you for your time and arrangement. So thank you. Thank you.
Thank you very much, Dr. Mohammed. It was a very informative session. And I would also like to thank the attendees for taking their time joining us. I hope you did also get something from this session. And you guys have a great, we'll enjoy the rest of the day, and I will see you on the next one.
See you. Bye.
Thank you. Bye-bye.